So this video will talk about the factors that affect the rate of enzyme reactions. The first one is temperature. At low temperatures, enzymes become inactive, so the reactions will be slow. Now these are substrate molecules and these are enzyme molecules. At a low temperature, they tend to move very slowly. So by moving slowly, because they don't have much energy to move, it will lower the chance of them bumping into each other to start a reaction. So this will cause reaction rates to be lower. On the other hand, if the temperature is relatively higher, then this means that the substrate molecules and the enzyme molecules get more energy. When they move faster with more kinetic energy, then there will be a greater chance for the enzyme and the substrate to bump into each other. When this collision happens, reactions will happen. So by moving faster, you have a greater chance of reaction and a higher reaction rate. Now, when we talk about temperature, it is important to note that when the temperature gets a little too high, what happens is the shape of the protein or the enzyme is going to change. When the enzyme changes in shape, we say that it is denatured. And when it is denatured, the substrate that originally fits into the active site can no longer fit into the new active site. And therefore, no reaction will happen after the enzyme is denatured. So the temperature at which the rate of reaction is the highest, that means when the enzyme is most active at a high temperature but not denatured yet, we call this temperature the optimum temperature. This is the temperature when the rate of reaction is the highest, when reactions take place the fastest. In many enzymes in the human body, the optimum temperature is slightly higher than 37 degrees, our body temperature. The second factor that affects the rate of enzyme reactions is pH. For pH, if the pH is unsuitable, that means if it is too acidic or too alkaline, it will also cause the enzyme to change shape. So most enzymes will only work well in a very narrow range of pH. For example, the pepsin or the protease in your stomach, it only works well in very acidic conditions, and that's why you need hydrochloric acid in your stomach. The last factor that you need to learn about what affects the rate of enzyme reactions would be inhibitors. Now, these can be toxic substances like cyanide, or heavy metals such as mercury ions and lead ions, or even other environmental pollutants. For any of these inhibitors, when they are mixed with enzymes or when they go into our bodies, they will slow down or even stop enzymatic reactions. And usually we say they're toxic because they will cause certain reactions that keep you alive to stop.